Last subtopic of first order circuit, the step response of a RL circuit. Similar like step response RC, the voltage source here in this basic circuit of step response RL exists when T more and equal than 0. So when the switch is on, the figure of A will be transformed to figure B, or the line here is connected together. For RL, we are interested to find the current that flow in this inductor, or V equal to LdI dt, but this is the current. Current is the parameter that we are interested to find first. Okay, when T less than 0, or when T equal to 0, the current or the initial current is symbolized like this one. This is initial current. This is current when T equal to 0, just right after the switch is on. And this is the current when T less than 0. All are same and can be represented as initial current, I naught, when T equal to 0. Final inductor current is for this one, which represent the I of the current of the inductor when the switch is on, meaning that the voltage is in the condition of charging the inductor. So I infinity, the Vs over R. Infinity means the T until T up to infinity, the I will be saturated to the value Vs over R. And time constant, tau, is L over R, similar like the source-free RL circuit. So this is the main equation for the current in T domain of inductor, Vs over R plus I naught minus Vs over R e negative T over tau, and times with the unit step T, represent the abrupt changes of the voltage in the circuit, meaning the voltage is suddenly applied in the circuit. How the formula is derived, or how the formula is produced, is not shown in this slide. Maybe you can refer to the reference book, but it is using KVL to derive the equation of this circuit, and then finally produce these equations. And this equations is matched with this basic step response of RL. For general, maybe the circuit advance become complicated, don't use this equation. Use these equations. It is more general for step response RL, because if you use this one, Vs over R, so you must change the complicated circuit or whatever circuit to this basic step response RL. Think better, use this formula. We will learn later on how to use this formula in the example. Okay, in conclusion, to find the step response of RL, first we need to find the initial inductor current. I know this is when T less than 0 or the switch is still open. The final inductor current, I infinity, when the switch is on, the current source is exists in the circuit, and the current is flowing to the inductor, and time constant, which is in inductor L over R. Okay, and in step response RL, the situation of the term like steady state response, transient response also exists, but it is not covered in the slide because it want to shorten the knot but it's whatever stated in the RC, for example, the graph is also exists in RL. Like this one, RC circuit, the Vs is saturated when T close to infinity, but in RL, of course, this is Is, and Is will be saturated when T close to infinity. Okay, let's see the example of this formula, yeah, this formula of step response. Example 9 for step response RL. The switch in the circuit shown below has been closed for a long time. It opens at t equal to 0. Find IT referring to the current for inductor when t more than 0. So first we need to analyze the circuit in two conditions. One is when t less than 0. Remember that we will use this formula to find the value of IT. So there are three elements that we are required to find. I naught or I initial, I infinity, and tau, L over R. Okay, back to here. When t less than 0, the switch is actually closed, switch on, because here has been closed. So the switch is on, the line here is connected. So the circuit supposedly will be like this. Resistor 10, short circuit, the inductor will look like short circuit. This is straight line, and another one is the resistor of 5 ohm. Then here is the inductor that we want to find, or I naught, yeah, 3 ampere. So how to find I naught? In principle of current flow in the circuit, 3 ampere will flow up until this line. At these junctions, the current will be divided into three ways. One at 10, and a second one is at the straight line, and the last one at 5 ohm. But since this is straight line, the current will only choose this line, because the current prefer the root to the ground that has no resistance. So it will avoid this 5 and 10 and just go straight with this straight line that has no resistor. So this will be no longer in the circuit, and this also will be no longer in the circuit. The current will directly flow from here to this up until back to the ground here of negative 3 ampere. So I infinity here will be same like the value of I source, which is 3 ampere. Okay, next we need to analyze the circuit when t more than 0. In circuit for t more than 0, we are required to find the value for I infinity and the value for tau, L over R. Okay, since at t equal to 0, the switch is lifted, means it's open circuit. So this line will be no more in this circuit. This still become the straight as a short circuit straight line. But 3 ampere here will split into two, one at 10 ohm and another one at 5 ohm. Because this is straight and this is straight, and after that there is a resistance. So both lines have resistance. So the current are split into two values. Okay, but remember we are interested to find the I infinity. I infinity means the I that flow in the inductor when t more than 0. So I here Here is still 3 ampere, but here it will be split into 2. So we can use current divider. In order to find the I that flow through this short circuit inductor and also this 5 ohm, it is 10 over 10 plus 5 times with the 3, and we will get 2 ampere. Okay, and how about R? R here, see from the inductor here, the resistor will be 5 and 10. This is series, but disconnect the current source here. If the current source is disconnected or removed, it will become open circuit. So the only left is 5 and 10. That's why 5 and 10 ohms becomes the series resistor. So just 5 plus 10 is 15. We can straightly calculate tau, and is given 1.5, and R is 15. Okay, this slide shows the solution of example 9, but the difference between this slide and my previous method here is this slide transform the current source and the parallel resistor in this circuit to voltage source and series resistor. If you still remember, the source transformation is transform this into voltage by 3 times with 10, you get 30 volt, then change this 10 ohm with series connection to the voltage source. Okay, and then the principle of inductor is the same, it's short circuit, and this becomes straight line here. Straight line here, and there is no 5 ohm because it's straight line. The 30 will divide by 10 to get the answer for I. That's why 5 ohm is not included in this calculation of I naught, because current will flow through this line. Okay, settle with this one. Next is the I infinity. Okay, similar like the circuit of source transformations. I infinity here, because this is open circuit, so this line don't consider this line, just 10 and 5. So straightforward, this is like I source, whatever flow through 10 ohm will flow at 5 ohm. So 30 divided by 15, that will get the same value like previous method, 2 ampere. Okay, and a resistor here using this method is easily can be seen. 5 and 10 of course is a series because the current that flow is the same value. So straightforward, 10 plus 5 L over R equivalent 0.1 second. So the 3 elements of this equation are obtained. So now we can insert it directly to this equation, and finally we will get 2 plus E negative T over 0.1. And don't forget to finish these solutions because there is no T. So up until there. Okay, next we continue with example 10. Example 10 solution is a bit difficult because this circuit has 2 switches, S1 and S2, and the time for switch on is different. Okay, see S1, the time for switch on is T equal to 0, while S2, the time for switch on is equal to T equal to 2 seconds. Okay, we are required to find the I for the inductor when T equal to 1 and 3. So to analyze this circuit, we have to analyze this circuit in 3 conditions or 3 time interval. 1 when T less than 0. Okay, when T less than 0, S1 here is still switch off, and ST also is switch off. S1 and S2 is off. So the only component involved is 6 ampere and the parallel 15 ohm resistor. So no current will flow through this inductor. So I naught here will be 0 ampere. So this 0 ampere is the kind of example initially uncharged for inductor, because initial current for inductor is 0 ampere. Next is 0, analyze 0 circuit when time is 0 less than t, test t less than 0, which refer to the condition of S1 is on, yeah, when t switch on, T2 is still switch off, okay, and the circuit involved only this become switch on, this become connected, current will flow 10, 20 and 5 Henry, but this one is still disconnected, so this one will be disregarded in this, or will be not seen in this circuit. Okay. The last time interval is when t more than 2. This is the condition when S1 is still on and S2 also will be on, okay, up until infinity. So when S2 on, this line will be connected, so but this will be no more seen in the circuit, or will be disregarded, because go back to the basic principle of current. The current prefer the line that it has no resistance. So the current from 10 ohm here will directly flow through this straight line, and then go back, flow to the inductor, go back to the negative polarity of 6 ampere. So this 20 ohm will be removed. So this is the 3 time intervals of circuit analysis that I've mentioned earlier. When t less than 0, I naught becomes 0 ampere. It is good if you can draw the circuit according to this time intervals, because it will assist you, the circuit will assist you in analyzing the circuit, and marks will be given for the drawn circuit, because it shows that you understand the operation of the circuit according to this time interval. Okay, continuing back here, when 0 less than t, t less than 2, there's the switch. Remember, the switch up here will be open circuit, no line will be considered up here. So we just need to find IT. We can use current divider. 15 over 15 plus 10 plus 20 times 56A. Remember, this one looks like short circuit. So you will get 2 ampere. Okay, for this circuits, this the R equivalent, or the tau here. We start to count the tau here for tau 1, because this is 0t, t then 2, tau 1. These are equivalent for the tau 1, because tau is L over R. So L is still the same, 5 Henry, but R equivalent here is 15 plus 20 plus 10. This is like, remember, current source, to disconnect or to remove the current source will be I is equal to 0. I to 0 is similar like open circuit. So no more this one. That's why inductor C distance 20 and 15 ohm as a series connection. 45. Okay. Settle for second time interval. Next. Okay, before that, finish the R equivalent here with the calculation of tau. So tau 1 will be 0.1111. So this is up until here. We already collect, or we already prepared with the value for I naught. I infinity and the tau here. So we can insert this into equations of I infinity I naught minus I infinity e negative t over tau. And we will get 2 minus 2 e negative 9t. Okay, remember that I naught here initial is 0 due to the initially uncharged condition. Okay, that is settled for the first and second time interval, and S1 is closed, S2 are open. Next, we continue for t more than 2, S1 and S2 are closed. So the initial, remember, starting from here, when t more than 2, the inductor now has a value. What is the value for inductor? For this S2, bring back the value here. So continue. The inductor current, this is I naught here. Initial condition for this one. For this time interval. Not 2. Like this one, yeah? Okay. So just insert 9 here. According to the time when the switch is on, so 2. So bring the equation here, 2 e negative 9 times 2, we'll get 2 amperes. This become the I initial for the that time interval. Okay, because just bring the value of current to here, 2 ampere. And this is I infinity for the second part. I infinity, just find the I infinity. Now this 2 ohm is no more, only this straight line, and we can find this IT. This become switch on. IT is just use current divider. Also 15 divided by 15 plus 10, only resistor exists only 10 here. It's time with the 6 and we'll get 3.6 ampere. So just use back this formula. Okay, before that, find the R equivalent. R equivalent same like the method here. Okay, disconnect the current source, meaning open circuit. So this will become 15 plus 10, 25 R equivalent. This is R equivalent number 2. Yeah, for the third time interval. Number 1 is this one. R equivalent is 45 ohm for the tau 1, and number 2 is 25, and the tau 2 is L over R equivalent 0.2 second. You can symbolize this tau T1, tau 1, tau 2, R equivalent 1 and 2. It's up to you to differentiate the R equivalent and tau, or you can just state it here. For T more than 2, the condition of R equivalent is this one. For 0 T less than 2, the R condition and tau is this one. So it's up to you whether to differentiate the R equivalent or just left like this one. R equivalent for this time interval and this R equivalent for the third time interval. So straightforward. Don't insert the different value. Remember, this is the value that we calculated here. 2 ampere is the I naught. I infinity is 3.6. And then T, there is another difference in the calculation in the formula here, because T now refer to not 0 but T minus T naught. T naught here is the switching time of switching to T minus T naught over tau. So this is the only difference between calculating of IT when S1 and S2. Again, 2 is due to the switching time of T S2. Okay, so after we have found the IT, the complete IT for the third time interval, we can write in a better form like this thing. T less than 0 is 0, 0 less than t than 2, 2 minus 2 e negative 90, and this is the third time interval, t more than 2, this is the value. So go back to the questions. We are required to find 1 and 3. So 1 is here, 3 will use this formula. Okay. So 1, to find out 1, just insert the t with 1, so you get straightforward. Now the value 1.99 or 2 ampere. But to find I3 here, okay, use this the last formula and replace the t here with 3. Okay, so calculate with your calculator, you will get 3.59 ampere. Okay, that's the solutions. It looks a bit complicated, but it needs practice for you to understand. And then this kind of question also is usually appear in tests. Please understand this type of questions of two switches in the circuit and analysis using 3 times of intervals.